Welcome to this explainer. Okay, we are right in the middle of a massive, literally industry-altering paradigm shift when it comes to software architecture in the age of AI. Here's the core thesis we're going to unpack for you today. AI is making the actual act of writing code incredibly cheap, like unbelievably fast and cheap. But, and this is a big but, because generating that code is no longer the bottleneck, understanding how to structure it, system design, that has become the ultimate developer superpower. We're essentially moving away from just being syntax typists to becoming true system thinkers. To help guide us through this whole transformation, we've got a quick 6-part roadmap. We're going to cover architecture in the AI era, the fundamentals of good system design, data, quality, and security. Then we'll look at AI systems and copilots, how to avoid technical debt, and finally wrap up with the future of programming. All right, Section 1, Architecture in the AI Era. Why system design matters more when code gets cheaper. So pose this question to yourself for a second. If AI generates code faster, does that automatically mean it creates better software? The short, absolutely undeniable answer is no. Fast code does not automatically equal good software. Seriously, if you just ask an AI to, say, build an app without setting any real structural boundaries, you might get a totally plausible-looking interface on the surface, but underneath, it's going to be a tangled, unmaintainable mess. There's this fantastic quote from the 2025 Dora report that perfectly captures this. It says, AI amplifies the strengths of high-performing organizations, but also the weaknesses of poorly structured ones. You see, AI is just an amplifier. It's not a foundation. If your team already has clear workflows and a really solid architecture, AI is going to make you fly. But if your organization is already kind of chaotic, well, AI is literally just going to help you generate broken pieces of software at an unprecedented speed. Think about it like this. AI is essentially a super fast, completely tireless bricklayer. It can lay thousands of bricks an hour. That's coding. But architecture, that's city planning. And without a city plan, your incredibly fast bricklayer might just decide to build a massive wall right across the interstate or, put the plumbing right in the middle of the living room. AI desperately needs your blueprint. Which brings us to Section 2, Fundamentals of Good System Design. Boundaries, modularity, and layers. Okay, so your absolute primary defense against that AI-generated chaos I just mentioned is modularity. Basically, modularity means breaking your software down into distinct parts, bundling related responsibilities together, and hiding the messy internal details behind clean interfaces. It's all about grouping things logically, like putting all your user authentication logic in one specific place and making sure it doesn't unnecessarily rely on your payment module, right? Because without modularity, an AI will happily generate these massive, intertwined files where just changing a button color somehow completely breaks your login screen. Now, once you actually have those modules, you have to decide how they're going to live together. You're constantly weighing options, like do you go with a simple monolith, which has low operational complexity but can be tough to scale? Or do you go with distributed microservices, which are highly scalable but come with a ton of operational complexity? The really crucial point here is that there is no universal perfect choice. It's entirely context dependent. An AI might eagerly suggest building this wildly complex microservice architecture just for a simple prototype, which is massive over-engineering. Actually, a well-structured monolith is very often the smartest starting point. Let's move into Section 3, Data, Quality, and Security. Architecture is information architecture. Whenever we talk about system quality, we're talking about attributes like speed, scalability, availability, and of course, security. But here is the harsh truth, and it's something you really can't ignore. These attributes constantly compete with one another. They're at odds. Designing a system is really the art of navigating trade-offs. It's a conflict between two or more desirable things requiring a strategic compromise. Let me give you a concrete example. If you demand maximum, totally airtight security with multiple layers of encryption for every single tiny action a user takes, well, your system speed is going to completely plummet and usability will suffer. An architect has to look at the actual business goals and decide where exactly is the right balance between keeping the data completely safe and keeping the app pleasantly fast. An AI can explain these trade-offs to you, sure, but it absolutely cannot make that final strategic business decision for you. And hey, speaking of security, integrating AI opens up some entirely new attack vectors that we need to be aware of. Frameworks from places like NIST and OWASP highlight major risks, things like prompt injection, where users basically trick the AI,
or unsafe output handling, where the AI accidentally generates malicious code. And a huge one, sensitive info disclosure. You literally have to map out your data flows and your privacy boundaries before you write a single line of code. You must know exactly what data is being sent out to an external model.
Okay, let's look at Section 4, AI systems and copilots. Using AI as a copilot and building AI-native systems. If you're building AI directly into your product right now, you aren't just hooking up a simple API anymore. You're very likely building something like RAG, Retrieval Augmented Generation. This is a prime example of an AI-native architecture. It's essentially how you get an AI model to generate answers based on your specific private company data rather than just whatever general data it was trained on. Let's walk through exactly how this works step by step. First, the user asks a question. Second, your system retrieves relevant documents by searching your database. Third, it assembles those documents into what's called a context window. And finally, in step 4, the AI generates the answer based on that context. Now pause and think about the architecture here. What if step 2 accidentally retrieves a highly confidential HR document that this specific user shouldn't even be allowed to see? If your system blindly passes that into the context in step 3, you've got a massive data leak on your hands. Designing this stuff requires incredibly strict access controls. Next up, Section 5, avoiding technical debt. The hidden costs of AI-generated code. So let's talk about technical debt. Basically, this is the future extra effort and cost caused by choosing a quick, unstructured design decision in the short term, taking a shortcut today. Now, it's totally fine to take on a little bit of debt for a quick prototype, right? But the real danger right now is that AI accelerates the creation of technical debt exponentially if you leave it unchecked. You can generate thousands of lines of code in mere minutes that seemingly work perfectly, but structurally, they're an absolute nightmare to update later on. The main culprits for this AI tech debt are actually pretty insidious. You've got acceleration without integration, which means the AI wrote a function that works great locally but completely ignores your team's broader naming conventions. Then there's invisible architectural drift. That happens when developers use AI to make hundreds of tiny, seemingly harmless changes that slowly pull the entire system away from its original clean design. And then there's missing documentation. But honestly, the absolute biggest danger? Over-reliance on AI. Just blindly accepting AI outputs without human review. Strong governance and automated testing are quite literally the only ways to keep this incredible speed from turning into total chaos. Finally, Section 6, the future of programming. From coders to system thinkers. So what does all this mean for us? Here is the absolute crucial takeaway for this explainer. The very role of the software developer is undergoing a fundamental shift. We are no longer just typists whose job is translating requirements into syntax. AI can do the typing for us now. Instead, we are becoming reviewers, integrators, and most importantly, system thinkers. Our true value now lies in really understanding the business domain, validating AI outputs, prioritizing quality goals, managing risks, and ensuring that the wildly fast outputs of AI actually fit together into a cohesive, secure, and high-quality system. To wrap up, I want to leave you with this provocative thought to ponder. As AI continues to rapidly automate the routine generation of code, which of your programming skills will remain truly indispensable? I'd argue it's your ability to think structurally, to deeply understand data flows, and to design systems that are actually built to last. That right there is your true superpower moving forward. Keep learning, stay curious, and start thinking like an architect.